g prime of t is a square root function. I'll write g prime of t. I will rewrite it so that it becomes 169 minus t squared, getting raised to the 1/2 power first. Convert any square root function or radical functions into an exponential form so that we can take the power rule when we do the chain rule, okay? So they want us to find g prime of t. We'll do that by doing the chain rule, okay? So here comes g prime of t. Bring down that exponent of half to the front. You will get half times 169 minus t squared. But remember to always subtract 1 from the original exponent. Half minus 1 is -1/2. Now don't stop there, because if you stop there, you know you're only doing half of the chain rule. You now need to multiply this by the derivative of the inside part. What is the derivative of this underlined part? -2t. Okay? Alright, I'm going to simplify this by multiplying this half by this -2t and put that in front. Well, half and multiplying by 2 will cancel out, but you see the t will still stay negative, right? So what will happen is this half and this 2 will cancel out, but you agree that you still have -t, right? Put that -t on top of the fraction. You know why I'm drawing a fraction bar there, right? Because the leftover part, that guy right there that I just circled, has a negative exponent. I'm going to send it back to the bottom. Okay, I'm going to send it to the bottom of the fraction. And let's put it back in the square root notation. So I'm doing two things. I am finding its own place, like it's got a negative exponent, so send it to the bottom. But also let's put it back in a square root format. So that is g prime of t. So I'm excited to know what we're going to be doing with this derivative function, but that's what we found for part A. They want us to write an equation for the line tangent to the graph G at t equals 5. Now remember, if you want to do your equation of a line, you need x value, y value, and then you need m, right? You need 3 things. Well, they're not using the letter x1 this time, but you know what I mean by, like, they're using t, but that's what the input value is. So we know the input value, the x1 is 5, but we need to find its corresponding y value. And we can do that by plugging in the y value into this function. So what's that gonna be? We plug in the 5 in here first, because that's what the y is going to be. I'll get square root of 169 minus 5 squared. Please be a nice number. Square root of 169 minus 25. Square root of what? Is that gonna be 4, 14? Oh, that's nice. Square root of 144 is 12. So super nice. Y value is 12. Now let's find m. And m, you can find it by plugging in the x of 5 into this slope cooker, right? This g prime. This is going to give us the slope here. So let me plug in 5 here and there, okay? So what's that going to be? -5 over square root of 169 minus 5 squared. Well, the denominator looks very familiar, doesn't it? I'm going to get 169 minus 25. We've done that down here. The denominator will give us 12. Because you see, we did that just now. That came out to be 12. So the bottom of the fraction for the slope is 12. So here's the slope. Slope is -5 over 12. Now we got my 3 pieces. We got our 3 pieces. We're ready to do the point slope form. So do y minus y1 equals m times x minus x1. So plug in all these x value, this m value, and the y value to write the final answer. So here we go. Y minus 12 equals negative 5 over 12 times x minus 5. And you can stop there. I don't really care for a slope-intercept form. I'm perfectly happy with point-slope form. So that is where you can stop, okay?